Okay, this is what you know. Some of you will calculate from here, but eventually manipulate and get here. Okay, so this is the gradient intercept form of a straight line graph. So how to draw a straight line graph? How do you draw a straight line graph? You will plot a graph of x against y. That means you will put your table of value, then all your x value, you plot it against your y value, okay, with gradient as m and y-intercept as c. So if you plot your graph accordingly to the points that you have, your x against y, right, you will get a straight line graph, and then go and calculate the gradient by using rise over run. Okay, and then the y-intercept is this value that you read here. So as long as you can make whatever equation that you are given into a linear graph, then you can always get the trend accurately.
So you must always find the y-intercept.
Just wake up, huh? I go through the E-math quiz just now, you got pay attention. You missed the entire chapter, remember? I look at the messiness of his hair, I can't bring myself to do that. Wake up, no time already. 2 weeks, no, 3 weeks time is your WA3 for math. No leh, your E-math is week 7, is it? So 2 weeks time 2 weeks time.
Sorry?
And we have finished quite a while ago.
Can we just do e-math like to next week and then like push back to your...
Can we do what? Quiz, right? Yeah, but I must finish my marking first, because now my marking is about this tall. I just finished like that and throw back to my sec 4. So now I still got like that. You know, like Lee Kuan Yew got this magical suitcase, right? I got this Hello Kitty bag. Inside all marking.
Whoever govern Singapore must...
That day I thought I brought that bag back because every day I bring, right? I bring to and fro. I thought I left it on the Grab car. I almost fainted. Because it's like all your work, right? Then I come back and tell you I lost the entire cane. Very sad. Okay, anyway, if you look at this, if I ask you to plot y against x, right? It will be a curve. Okay, it will be a curve. Because what do you all learn about y equals to 1 over x? What is the shape of the graph? Do you all remember? Show me your hand. How does the 1 over x look like? Where got like that? Like that. You all got study or not? Got study or not? The tail look like he's like dancing. Like this, 1 over x. Yeah. Okay? So if I just do my usual table of value, I do my usual table of value and then I plot whatever this is, it will become something like that. Okay, which I cannot predict trend. Very difficult. So I want to linearize it into y equals to mx plus c. So how do you think I should change this? My y settled already, no problem. I should plot my y against what? So that I can get this form. Can I split it so that I get something x plus c? Can I change it? No, we don't want to times yet. So can I split the a from my 1 over x? And then it's plus b. Do you see something? Can you see this is my
x minus 1,
x, okay, my new x-axis. That means I'm going to change my x-axis to 1 over x. Okay, so that means my new x-axis now is 1 over x. Okay, and then my gradient will be given by the value of A, and then my y-intercept will be given by the value of B. So in this way, my y-intercept and gradient don't have any variables. It's always a constant. Yes, Amshi. Yes. The front part only. Only the front part, the linearizing part. The 9.1. Probably until
Isn't the second
page 7.
Isn't the second equation already done?
Not yet.
Why?
So first if actually I can, right?
Y
Okay,
can be x,
actually I can let my y-axis be this. Okay, that means my y-axis, I go and find the value of xy, which is possible. Okay, then this is my x-axis, and then my gradient is A, and then my y-intercept will be given by B. So this is feasible.
So do you take cursive class?
Cursive, no. What?
What I did was I divided it
By x. Okay, so actually you can, if you want to divide by x throughout, you will end up having this.
Yeah, then I just did the same thing you did.
Correct. So this one you will be plotting y against 1 over x. And then your gradient is b. Your y-intercept will be A.
Is that correct?
Correct also. Okay.
Then the xy is
Y-axis.
but doesn't it have to be y first?
Correct. So normally your experimental value is like that, right? X and y. Okay, let's say you get this one is 1 and 3. For example, 1 point. So in order to draw this straight line, now you need to tweak it. That means your x-axis is still x, so I keep my x value as 1. But now my new y, right, is x times y. So you have to go and multiply this and give me this value as 3. So if let's say this is 2 and, 5. So when my x is 2, my new y is the product of these two, which is 10. So you must go and calculate your new y and your new x. The y can be anything. So your x and y axis can comprise of variables only. But your gradient and y-intercept cannot have any variable attached to it. So that one is the rule. Okay, so what about this one? Next one. What is my y? Okay, so divide everything by x. Okay, so my y-axis would be y over x. My x-axis would just be x. My gradient is A, and my y-intercept is B. Okay, can you see that? So just keep following through. Okay, what about the next one? How can I get my y, x, and gradient and y-intercept? Divide? No. Okay, so we multiply throughout by square root x. So square root x times square root x, the square root disappear. Right? And then this one is gone. Okay, if you multiply throughout by square root x. So now my new y is this. Okay, my new x is just x. Then my gradient will become A. And then my y-intercept is B. Sorry? Square root times square root, the square root disappear, remember?
But what will become x? Like,
Yeah, that's why left x gone.
then what is the other x cancel?
This one and this one cancel out, ma. Yeah. Okay? What about the next one? What if it looks like that? Then actually, the hint is to switch their position first. So that you get ax plus b equal to 1 over y. So what is your y now? Can. This one, right? So this is your y. What is your x? This thing here. then your gradient, your y-intercept. So the idea is to find your new y and your new x. We cannot square expression. It will be a different expression. Can. Yeah, we can only multiply, but we cannot square the whole expression.
Like times square root x.
Ah.
Then it will be square root x.
No, this one cancel out, ma. The square root x and square root x cancel out. So left b
After
only.
this, it is times.
So square root x times square root x, this one left x, right? And square root x times y. Can you see this one? Square root x. This at the bottom, it can cancel off. No more already. No, it's like the whole thing. I multiply by square root x. So this one times square root x, this one times square root x, this one times square root x. All three terms. Yeah.
Should we just finish the rest by ourselves?
Okay, so quickly finish this one up. What should I do next to find my divide by x throughout? Or y, yes. Now you are getting it. So if I divide by x throughout, then my y is y. Okay, sounds funny. My y is y. Okay, then this one, my x is y over x. And then my gradient is 5 and my y-intercept is 2. So it's not always the case that y must belong to the vertical axis. I can also have y at the horizontal axis. So it's up to you. Okay? So this one, what about the next one?
What's stopping us from just doing?
No change. So this one is my y. This one is my x. Then my gradient is just the 1 in front of it. And then my y-intercept is 1. Okay, you will get better, right? So what's next? Y. What about my x? 1 over x squared. I split this into 2. So my gradient is h, my y-intercept is k. Okay, these three are the ones that brings in ln or log. Okay? Usually when you see exponential, you bring in ln. But when you only see numbers, you bring in log. But either case, both are acceptable. So I want to split this up. So how do I split this up? First step, I'm going to ln or log both sides. So let's say if you prefer log, so I'm going to log both sides. Okay, so this one no problem. This is my big Y. I need my mx plus c. So we know that when it's multiplied inside the log function, we can split it into 2, which is this one. Okay, and then my power n can be brought down. So this power n, after I bring down, okay, can you see what is your y, what is your m, what is your x, what is your c?
Log A is C.
Log A is my c, because log of any constant number, it is just a constant number. So don't, because you see log, you get scared. So this is c, no problem.
And N is the
N is my gradient, because it has no variable. So this will be my big X, the new X that I create. This will be my big Y.
Does the A stand for something? Or is
A is just a constant number. Can be any number we use for the equation. Okay, so for example, okay, maybe I use real numbers so that it looks friendlier. So for example, like that. So this is my expression. So in order for me to linearize this, I need to make sure I have my gradient, my x, my y-intercept. So I'm going to log both sides. Okay, when I log, I know I can split this into 2 by bringing in my addition log. Okay, so this is still my log y. So this is just a constant number. You go and press log 3, it is just a string of numbers. So this is my y-intercept. This is my c. Okay, and then any power you have, you should always bring it down as a constant in front of it. So this is actually my gradient. Okay, and then this is my new x-axis. That means I will plot it against log x. And then my vertical axis will be log y. So in your table of values, you will need to go and calculate what is your log x value, what is your log y value, before you can plot them. Originally, the table I give you is x and y's. But now, before you can plot the linear graph, you need to go and find what is your log x value, what is your log y value. So you need to form a new table of values in order to plot your new straight line. But it's all derived from your original graph. Okay? So what about this one? Same thing, if I ln now, it's the same rule, it will be ln A plus x ln B. Yes. Ln or log is the same. Okay? So what is my y-axis for this example? This one. So ln y. Can be log y also, it's the same. What is my x-axis? Just x. Then gradient is ln b. And then my y-intercept is ln a. So remember, the ones with variable can be your x and y axis. Those constant are all gradient and y-intercept. Okay, last one. When it's exponential, use ln. Okay, so ln y, I split this into 2. Ln a plus ln e, and then I bring the bx down. So I know ln e is 1. So actually this one is trivial. So what is my y-axis? Ln y. So this one. What is my x-axis? Just the x. So my gradient will be b, and then my y-intercept is ln a. Okay? Yes. Because it's the variable. It's the only one with variable. The b is a constant number, so cannot be your x-axis one. Yeah. Okay, so this whole process is whatever non-linear equation I give you, you can linearize it into a y equals to mx plus c. Then you plot a new graph and it will be a straight line. Okay, that you can use to predict trend. So the whole point is to make sure you get a table of values that you can plot straight line. Yeah, ln e is 1.
Why is x not the gradient?
No, x is a variable. Log b is the gradient.
Oh.
All those with x and y will be your variable.
Then the y is not gradient.
It's not. Because this one is constant. A is a number, like 5, 10.
Then what's the difference between these two?
The x is in the power. This one is n. N is a constant term.
So x is always a variable.
A variable.
Oh.
Yeah. Okay? Can So this is just the linearized process. Yes. X cannot be gradient because x is the one that will keep changing. Gradient is a fixed value. So this is the variable. So this is your x-axis. So this must be the gradient. Yeah. So remember, because x value, when we plug it in, it keeps changing, right? So gradient cannot keep changing one. For a straight line, must be the fixed value. Can Okay, let's go to the next page and see how a typical question looks like. This one not typical yet. This one just proving to you how to linearize.
Teacher, right? It looks kind of.
Wait, I haven't reached there. Done. Not. Okay, so here. This is my normal curve. One look at it, I know it's a quadratic curve that is shifted up by 3 units. I know this is the shape that I'm going to get. So if I plug in 0, 3, okay, then I have 1, so it's 5. Okay, then 2 is 4, then 8, then 11. Here. Okay, and then 3 is 9, 18, 21. Okay, here. So if you were to draw this, this is your curve. This is how you normally will plot it out, but difficult to extrapolate because you don't know the trend after that. Okay, unless you sub in and keep finding, right? Okay, but when we linearize it, we know that this is your y-axis. Okay, this is your new x-axis, x squared. This is your gradient. This is your y-intercept. So when I plot, I will plot x squared and y. So can you see that this is y, but this is x squared now. It has changed to x squared at the bottom. So be careful. So my x value, instead of using this, you need to square all of them. So square, 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 square. So that's why you get, this one is 9, right? X squared is 9. Then this one is 1. Aiyo. Okay, but the y value don't change. So it's still 3, 5, 11, and just now that one was what? 21. So I plot the points now out. So 0, 3, 1, 5, 4, 11. Okay, and then 9, 21. So when you draw the line of best fit. Okay, but usually the points we give you won't be like physics, so authentic, so far away. Okay, but it will be roughly similar. Sorry? Because x squared, 3 squared is 9, they count wrongly. Yeah. Okay? So actually, right, when we write this, right, it should look like this. Okay? But what we are plotting right now is actually this. Can you see? Okay, I'm just showing you. This is the original one we draw. It will be a curve. Difficult to predict trend. But when we linearize it, we are changing your x squared into your x-axis, the big X. Okay? And then your y is the big Y. And then when you draw, actually this straight line has gradient 2 and y-intercept 3. So you have linearized it into a straight line graph. Yes. They are the same relationship, but this one can help you predict the gradient, the rate of change. Okay? Yes. Yes, because we have, in order to linearize it, I need my x to be x squares. So you need to square all the values you have here, and then continue to use the y value. Yes. The curve is the original one. But when you linearize it, actually what you are doing is y equals to 2x plus 3. Because you have converted your new x to be x squared. Okay, so this is the new straight line that you have done.
So let's say it's x cubed, right? You just do the same thing.
Yes, so that means your x, you have to cube it. Okay, so if I give you this equation, how should I linearize it? This is my new y, right? This thing is my new x. And then my gradient is actually 1. And my y-intercept is 1. So actually when you are drawing, when they say sketch, right? When you are drawing, you are plotting this against this. And then when you draw the straight line, you need to make sure it passes through your y-intercept at 1. And the gradient is 1, positive. So you just draw something like that lah, sketch. Sketch doesn't matter. Positive gradient pass through 1. Then you can give me this as your equation. But you know it's this. Actually, this is a y equals to x plus 1. So I usually like to use capital letter X and Y to represent my linear graph so that I don't confuse myself. All the original ones are small letter X and Y's. So when I linearize it, actually this straight line that I'm drawing is y equals to x plus 1. Okay, but originally, this is my new y value. This is my new x value.
You did divide by x.
I don't need to divide by x.
Times.
I just use this directly. Yeah. And gradient up or down. Yes. Okay, but they won't ask you to sketch. They will usually give you the sketch. So example, if let's say I already have the x values, right? 1, 2, 3. Then when you find the new table of values, you must go and find my square root x. So 1, square root 2, square root 3. So when you are plotting the square root value. You don't plot this one anymore. You are using this to calculate your new x value, your new y value. So instead of using this, you will find what is your x times y. So you multiply these two values and put here. So your table of values will change. Yes. Write both what? No need, no need. So actually what you are drawing is this one. But it came from your original curve. Yeah. Yes. How do I get my linear expression? Because this one is my y, right? This one is my new x. So my gradient is the number in front of it, which is 1. And then my y-intercept is c. So actually I'm drawing y equals to x plus 1 in the new straight line. Because if I write this way, I'm drawing a curve. If I write the original form, it will be like me drawing this curve. But if I write it in this way, can you see that now this is my straight line? Yeah.
Isn't that kind of unfair?
Right.
You take away the x from the y.
Take away the x from the y.
Because if
No, I'm just using this as a big y. So now my vertical axis is the x times y value. I never take out anything. Yeah. Okay?
So is this to convert a curved graph into
To a straight line graph. Linearization.
Wait, but this one, how do you get the square root x times x?
No, this one is I'm just showing you your new table of value. You must square root all the value. Because your new x is a square root x. So if originally I give you this set of data, in your new data you must square root all your x. Because that's the new thing you plot.
How does that remove the x from the left hand side? The xy.
I never remove because this is my original graph, right?
Yeah.
So now I'm using this as my y-axis. So instead of calculating y, I'm calculating x times y because this is my y-axis. Sorry? What do you mean, how does it change? So my new y value that I calculate, right? It must be a product of these two numbers because it's a x times y. So assuming that y here is 5, then I must put in 5 as the coordinate here. Normal x is 1, right? So my x coordinate must be square root x. Because now I'm plotting xy against square root x. So my new x value must be square root x. So I must square root all my x values. Okay, later I will show you all when we start drawing, right? Then your new table of values come in. Now we are not really drawing, so you can't really picture it yet. Okay, so example. So next, this one. So this question say, can you show that I will get here? What should I do to get here? Okay. This one. This is the typical one. So how do I get from here to here? What do you think they do? Okay, so divide by xy throughout. So everything divide by xy, xy, xy. So the x cancels out, so I get this. Okay, the y cancels out, so I get this. The x and y cancels out, so I get this. So part A, how you show is that you will copy this expression and then you write divide by xy. Then you can get this shown. Okay, but how do I linearize it? They already gave you a hint. They tell you that your new y and your new x must look like this. It's always plotting y against x. So that means the graph that you sketch will be 1 over y against 1 over x. So if my y needs to be 1 over y, what do you think I need to do? How do I get there? First, I keep my y on one side first, right? So this is my y. So I'm going to leave this as expression here. So I'm going to bring my x to the other side. So become like that. Correct? Okay, and then I don't want the 2 in front. So I will just divide by 2 throughout.
I thought y is fine with having.
Y is this. Okay, so what you are plotting is actually the straight line y equals to negative 5 over 2x plus half. So your linear graph is a downward graph passing through the y-axis at half. So when you sketch, you are sketching a downward slope graph that passes through the y-intercept at half. Yes. We are used to replacing it as y equals to mx plus c. So this is my new y, this is my new x. Yeah. Okay, so when you sketch, actually all I need to see is this.
Didn't we do this?
Cut at half, the gradient is downward sloping.
Teacher, I remember we did in one question last year. It was the last question for the y.
That one is suitable line different.
No, I remember it's because there is one here, right? And then you're supposed to make this equation.
Yeah, so that one is finding curve equals to straight line. This one is we are making a curve into a straight line. Yeah, yes. If you want, actually you can from the very first beginning change this to y, change this to x. Then manipulate until you get y equals to mx plus c already. Okay, if it's better for you. Okay, so the idea is they just want you to... But O-level never ask you to sketch at all, ever. Okay, no need to sketch one. This one is just for you to...
Whose idea was this to add this on that?
Because they want you all to, you know, use thinking routine.
Wasting paper.
What if you are given this graph?
B for wrestling.
Okay, so now, the highlight is this. What if they give you the sketch? Can.
Okay, sure, I had 2 marks.
So the whole thing is that the small x and the big X will confuse you. You must think like, when am I using big X? When am I going back to small x? When I'm thinking in terms of the straight line, I'm referring it to the capital letter X and Y because I'm looking it as if it's a straight line. But when they want you to calculate the original small x and small y, you need to think back to the curve. So that is the difficult part. Okay, I'm not worried about y'all cannot get the linear graph. I'm just worried that y'all cannot switch between the linear and the non-linear part, which is the difficult part for part 1. So, with that being said, please wake up and pay attention to the next part. Okay, wait. I finish this part first, then I can give a... They give you the sketch. And this is your big Y. And this is your big X. Yes. Operate. Okay, this one. So now I want you all to operate like a straight line. So this is indeed a straight line graph, right? Although they tell me what's the actual Y value representing, what's the actual X value representing, I don't want you all to think about the original. Think about the linear first. So the linear is like that. So ignore this one first. Ignore this and this. Don't even think about it. Because the values that they write here are the big X and the big Y value. That means this value X here actually represents X squared. This value Y here actually represents Y minus X. If you think like that, it's very confusing. So don't even relate to the original value. Because remember when we plot this, we are supposed to come up with a table of value. And this one is X squared. And this one is Y minus X. So the first pair you see here is not your X and Y value, you know. It is your X squared and your Y minus X value. So I don't want you to look at it like your curve. Look at it like your big straight line graph. So let's forget that this is even a curve to begin with. Let's just replace this thing with big Y and big X. And my original linear graph is this equation. Can you find the gradient of this straight line? So rise over run, right? So 4 minus 2. Okay. And then X minus 0. So this one will give you 2. So my gradient here is 2. Okay, then in order to find your y-intercept, you sub in any one of the pair. So for example, I choose 3 and 4. So this one I change to 3 and 4. Okay, I'm just going to give you a rough idea. So C is negative 2. So actually this line represents y equals to 2x minus 2. This is how the straight line graph is given by this equation. Yes, so this is the linear graph that you are writing. But what is the original curve? You work backwards. That means now put back your y value. Okay? Put back your x value. So actually this is your original curve. This is your curve. And this is your straight line.
This one. So
yes.
should we give them, which answer should we give?
So when they ask you for the original equation, of course you must give them this. Okay? So imagine if they say find the value of find the coordinate here if this x squared is 1. Then you ignore the fact that it's x squared, you know. You must know that actually you sub in minus 1 into the linear graph, this one, to find what's the y. So the code switching part is the difficult part. Okay, so before we get there, let's give you a 3 minutes mental break. Then we will look at the switching. Yes. Because it's 4 period, huh?
If they wanted us to submit the x and they give x squared, is it y minus
If they want to
submit into this one?
they will give you x minus x squared. And you know what
So it's still negative 1.
yeah, so you need to be careful. So the difficult part is that one.
Then we just submit the equation.
The linear law in O level sometimes 9 marks.
You keep the y minus x and y thing.
Right.
Like the y minus x.
Let's see the okay, when they give you the y value, but they never give you x. Yeah. Okay, this one they never give you enough. There is some in a bit, let's get there.
Can you just remove the space already?
Yeah, so thought
Like, these are all the noise.
actually don't need all this song. Okay, never mind, never
And
mind.
every other page is all. Oh my days.
Oh my days. My lesson. You don't have. Can you have a timetable? 12:15, huh? Okay, not much. Huh? That's all I have?
The 4 period we started at 9:55.
Oh my god. But it's so short. I barely taught much. Where's the 12:15? So sad. Okay, one more minute. I thought I still have at least like one more period. Yeah? I cannot. Chem also very important. Got announcement, is it?
I can't hear anything. Oh, I think got.
Yes. Yeah. 45. Yeah, so now time end already, right? I give you all 3 minutes break, right? Okay, shall we? 3 minutes is up. Okay, 46. Does the 1 minute make a difference?
Yeah, 1 minute's a lot of difference.
Okay, fine.
Yeah, just remember the CCA.
Okay, fine.
Now, what's your CCA? What's your CCA?
I used to be in guides, then netball, but now I don't need. Now my job function don't have CCA. Okay, ready? Hey, hello. 4 minutes already. Sit down.
It's not like 30 seconds.
Just now it was 43. No, 42. I say give 3 minutes, then you all say 1 more minute. Okay, ready?
You know Podoromo is like
Please come back, people. I need to buy the bell, for all the lost souls. You have one?
I mean, I can bring that.
Okay, use the online whistle.
Bring the voice.
Okay. Mr. Shu Huai and Miss Jia, please sit down. 没有办法，我们忍一忍。
像坐飞机一样一直坐着。
很站着。Okay, look at this. This one has been linearized. So now I want you to see it as big Y, big X. Ignore the original form first. So big Y and big X are. So I need to find the equation of this straight line. So what is the gradient? Y2 minus Y1. So ignore the original. Even though it like annoys you, but ignore. Okay, so this is -1. So my gradient is -1. Next is I will sub in 1 point. Any point that I like. So I choose 1, 4. And I will sub in into Y equals to -x plus C. Okay, remember my purpose is to find the straight line graph like how you did in Sec 1. Okay, so 4 is -1 plus C. C is 5. So my linear graph that I have sketched out here actually represents this straight line. So this is the linear form.
Can we just use the even bigger Y equals
Can. Also can.
even bigger X?
Can. So this is my linear one. But now the question say use your small x and small y and get back into the original curve. So I'm going to go back into my non-linear form. So instead of y, the big Y, this is actually a small y, put back. Okay, instead of my x, this is actually a 1 over x, put back. So what you can do is actually my non-linear form is y -1 over x plus 5. So this is my non-linear graph. Yes. You can sub, yeah, I sub into the equation to find C ma. Can. Also can. Yes. Yes, because you want to find the linear, you must have the ability to ignore. Like sometimes you all do little things. I have the ability to ignore. Okay? Yes. Yes. Okay. So now let's go a bit deeper. This one is like the friendly
Somebody who
appetizer. Okay, appetizer. Let's go a bit deeper. Okay, let's go a bit deeper.
I'm lagging.
Okay, so same thing. Big Y, big X. Because it's already linearized for you. So look at it like a linear graph. So my purpose is to find Y equals to mx plus c. Ignore what you see there. Don't want to see all the x and y axes, what it represents. So first, find gradient. So gradient is y2 minus y1. x2 minus x1.
So it's negative 6 over 7.
Okay, so like that. Oh, 6, 7. Okay, so negative 6 over 7. So in order to solve for the c, then I plug in one of the points. Let's say this one, 9, 1. And gradient this. So let's plug into the equation. 1 minus 6 over 7, 9 plus c. So your c happens to be not such a nice number, I think. It will be 61 over 7. So my big equation, my linear one, is this plus this. Okay? So if it scares you, you don't like fraction, then you multiply throughout by 7. So you get 7y, 6x plus 61. If this looks better for you. Okay, but the purpose is question say, can you find y square in, oh then don't because they can don't want. Okay, sorry, your teacher is being fickle-minded. Okay, so this is my original form. Now they say make it back into its original curve. So I'm going to plug my y.
So this is linear form.
Yes, this is linear. Better write clearly. This is my linear form. Now I'm going back into my non-linear form. So my big Y, I must change back to this not so cute expression. So change this to y square minus x. Okay. Then my x is root x. Okay, the rest I just keep. Okay, so they say can you express y square in terms of x? So keep the y square there and bring the x over, done. Okay, so y square is this thing plus x plus 61 over 7. So the order of it don't matter. Okay, then of course they say can you find the values of y when x is 9? You use the non-linear one. Because these are small x's and small y's. Use your original one. Don't go and sub in here. Because you will end up getting a different value. So when they say find the values of y when x is 9, put it into your original curve. Yes. No need quadratic. I think it will just be a number. Don't overthink. Yes. So if I go and calculate this, plus 9 plus 61 over 7, you get 106 over 7. Then because they want possible values of y, you have two answers. One positive, one negative. So 3.89 plus minus 3SF.
What do you think?
If you want to leave it as cert also can.
What do you think of a refrigerator here? So you can put your snacks.
A refrigerator?
So the chocolate doesn't come.
Yeah, and then we don't have to pay the electricity.
So still complaining that the chocolate not in the fridge.
Maybe it was good. It didn't melt after schooling it.
Oh, cannot. 106 divided by 2. Cannot. Actually, this if you leave it insert, is the simplified form already. So you can also leave it like that. Okay, so these are the two possible values of y. So the only difficulty is sub where. Which equation am I finding? Am I at the linear one or the non-linear one? So you all tend to be confused at this part. Okay, let's look at the theory one and the actual graph. Yes. Plus minus 3.89. Or you give me the cert. This one is the simplified one. So cannot simplify anymore. Or actually, if you want to simplify, you should rationalize the cert.
What's rationalized?
Yes, by right. Yes, but this one is not the most simplified because by right you need to rationalize. This one is not rationalized.
I'll just give it this.
So it will be 106 times 7. 742 over 7. So this is the rationalized one. Yeah. Okay, yes. Yes. No, just 3. Because this is a positive square root. They already use it like that. So we only use the positive value. Yeah. Yes.
Shouldn't it be negative 7 over negative square root 7? Because you must
No lah. I'm rationalizing where got reciprocal. I never bring up. Yes. This case, we don't need to reject because they want us to find both values.
Right.
The curve can have 2 possible value for your y. It depends. Okay, maybe the curve was like that. I don't know how the shape. So you have 2 possible values of y. One here, one here. Yeah, yes. For certs as a final answer, yeah, you will lose mark. So cert final answer must rationalize. Okay, next one. This one. Okay, this one just need you to tell me how you are going to linearize it. So this is a O-level question. Don't think it's a joke. It's a O-level question, 3 mark. Okay, so they say, I give you this equation. Can you tell me how you will linearize it and how you are going to find the value of P and Q? So if we want to linearize it, what do you think we need to do? Divide by x first, right? So I'm going to divide by x. So this one become Px, this one become Q. So I know that this is my big Y. So this is my big X. Excuse me, I can hear you. Okay, gradient. And then this is my y-intercept. So when you write, they ask you to state the variables that can be used for each axis. So actually this one, y-axis, you know that for the y-axis, it will be y over x. Okay, for the x-axis, it will be x. Okay, and then they say, explain how the value of P and Q can be found. So what I will do is I will have to plot a graph. Or if you want to be specific, a straight line graph. Okay, of y over x against x. So I'm talking about y, the big Y against the big X. So that means when I'm plotting my y-axis, y over x against x. So when you say this, the first one you mentioned always represents your vertical axis, your y-axis. So I'm going to plot a straight line graph of y over x against x. Okay, and find the gradient of the straight line to determine the value of this one, P. So if I go and plot out my straight line graph, the gradient that I found will tell me the value of P. Okay, and the y-intercept, okay, will determine the value of Q. Yes, because they say explain how the value of P and Q can be found from your graph. So they need to see what you are plotting, okay, against, how to find the P using gradient and how to find the Q using y-intercept. So 3 marks, 1 mark each. Your x and y axis, how you get the gradient, how you get the y-intercept to find the unknown. Okay, so this is a typical question from O-level, 3 marks. Usually, they either test this as one question, ask you to explain, or this is a part A. Okay, this is a part A. Then they ask you to explain. So you must know how to explain in words. Mr. Ashriel, don't fidget.
My name is Ashford.
Oh, they never give graph paper. How like that? Can you all use a digital one? Why you
You got no
cannot use digital?
You got no PR.
Okay, never mind. We plan first. Then you go home and draw. Okay, you go home and draw. No, I still have 15 minutes. You know how precious 15 minutes is? What lesson is about to end? Horrible people. Okay, anyway, this is the same thing from the question above. So I already know for sure that I'm going to plot this against this. So first step, in order to plot this against this, I want to plot my straight line, right? Your new x and your new y value, you need a new table of values. So this one first important thing. So this one is always your big X, this one is always your big Y. So my big X is just X, so no problem. I just copy 2, 3, 4, 5, 6. Because it's exactly X, so no problem, I just copy. But my big Y is actually Y over X. So I'm calculating my Y over X value. So you need to use 2.1 divided by 2. So 2.1 divided by 2, you get 1.05. So the next one is 11.7 divided by 3, you get 3.9. So calculate your new table of values first. If you don't do that and you draw, you will get a curve. Then you get nothing for the whole question. So don't be reckless. 6.9. 8.06 and 12.75. So this is your new table of values, and then you will draw out the line like as if you are drawing a straight line graph. Okay, as per normal. So with that being said, is there a graph paper that I can use?
Yes.
Okay, you all do your table